So we got transportation. Transportation, see again, it's demand and supply, just like you guys had in your economics, right? So again, now here's the thing. Where is the fly in the ointment, the monkey in the wrench? If it's balanced with the supply and demand, it's all equal signs and we're okay. But what happens if supply is greater than demand or demand is greater than supply, then we're working with the less than or equal, okay? So keep that in mind. We'll go over it. You'll know when to do it. 6 seconds in. A transshipment means that, see, instead of us, we go from the farm where we raise the grain. That goes to some transshipment place, a warehouse of some sort, and then that goes to a mill. It's a transshipment if there's that thing in the middle that's a warehouse, that the things go in, and then everything comes here, and then everything goes out from there. There may be 1, 2, or 3 of those warehouses. Again, we'll see these. Right? Then there's assignment problems. Assignment problems are the same things, but when you guys watching the NBA, sorry ladies, if, soccer I could say or something. Again, if these referees, can a referee be at 2 playoff games at the same time? No, they're going to send them to, either, to Miami, or they're going to send them to San Antonio or whatever, right? So one agent can only have one assignment if it's a balanced, right? Or, again, is it possible for us to have 3 students and the teacher being as worthless as what they are, they expect the students to do everything for them, but there's 4 tasks that have to be done. Maybe a task won't get done then because there's only 3 students and there's 4 tasks, okay? Again, just think about this. I'll give you specific examples. But that's what it is. Transportation, transshipment, and assignment problems, all righty? We're 2 minutes and 18 seconds in, all right? So again, same thing here. Transportation model. Now, you realize that you've got appendices in the back of your book, A, B, C, and D. Well, look at the one. The first one had to do with linear programming. The second one, the B module, has to do with transportation. So read those. We'll go over the northwest corner. You know what I'm saying? The northwest corner was in there. There's a VAM method. There's other methods. But if you want the very best and optimal price or cost, what do you think? What's the best way to do it? What's your word? What are you and me speaking about? What's our software that we have in common that you love?
I don't know which one.
Only one we use so far. Excel. Excel Solver. You're going to use Excel Solver, right? And to come up with that cost, you're going to have to set it up. But for the test, am I going to ask you to set that up? No. In the test, I'm going to ask you to just model it. So understand the modeling part. You don't have to actually do it. But in your spare time, in the morning when you wake up and then you get an aha in the shower and you go right over to the Excel and start typing in, that's when you're going to learn how to get really good at that, okay? So this is a computer solution, which is Excel Solver. Now, I would not use QM, right? Anybody using QM? Don't use it, right? I think it's the author probably gets some money for it or whatever. Transshipment model means there's a warehouse in between. Again, there's a solution for that. So we're going to go over the Excel solution. Then there's this assignment model. How many referees? We got 4 referees. We have 4 games to referee. We got so many miles in between. We want to be effective. We don't want to send the referees to the furthest place or to the shortest place. Shortest distance you got to go, right? Do we want to ship our wheat at the highest cost or the lowest cost? Lowest cost, right? So, again, it all makes sense, right? So we're going to go over the transportation, and then we're going to give you Excel. Then we're going to go to the transshipment. We're going to give you Excel. We're going to give you the assignment. We're going to show you Excel. That's basically what's going on here. So again, what are these? These are linear programming problems. There's special class of those. These are network flow because there's nodes and arcs here, right? Much like your PERT. You guys know PERT and critical path? Much like that, this is what we're dealing with here. Again, guys, not rocket science. It's not that difficult, and we're going to look at these solutions here. Now, I can tell you right now that first one's on the test. Are we going to send this at the maximum cost or the minimum cost? Do I want to say, yeah, minimum cost, right? Makes sense. And again, another question, which we'll go over here with this cheat sheet that I have, which is why you don't really need the book, right? Because you got this one and you got the PowerPoints and you got your friends, right? Remember, you got a friend in Pennsylvania, right? You got a friend in Jesus, right? You got a friend in me, right? And you got a friend somewhere in this classroom here, right? So work together as long as you understand. But again, we can go from, from the source directly to the destination, or we can go from the source to some intermediary in transshipment, and we can do any of the above. So again, I will point this out specifically to you here as to how it will be on the test. So 5 minutes and 45 seconds in, ladies and gentlemen. Now, where's Waldo? This is a balanced demand and supply. Somebody be the teacher's pet here and show me where the mistake is. You know what I'm saying? Just to reinforce to you how neither me, yes, sir.
The demand doesn't add up to 600.
And which one of those is wrong, do you think? Chicago, that's right. What should it be? 200. You're exactly right. So now, you tell me, how much did you pay for this book?
Too much.
Yeah. You paid that much money for the book, and they're going to put those kind of mistakes in it for you. And then they're going to put me up here, and I'm going to take the wrath of Khan for it, right? Yeah. No. Everything I say is with tongue in cheek. Believe me, you didn't read me out at all. We're in good shape, and you're allowed to say whatever you want. What I'm saying is, though, is the author here? No, I wish I had Taylor right here and smack him over the head. Can't you get the damn thing right? That's 2 of them so far, and so far what's happened? You've had 3 chapters, and there's been 3 mistakes in there. And they're wrong, you know what I mean? But hey, guys, like I said, it's life. You cannot, yes, sir. In the book, it's correct. Well, you know why? See again. Because we got the big professor. He writes the book. The editor looks it over. Now, he has to come up with the ancillaries. Who does the ancillaries? The graduate assistant. How much is a graduate assistant getting paid? Well, he's getting nothing, right? I think I got $800 a year, something like that, or maybe it was $8,000 a year, Southern Illinois for 4 years, you know what I mean? Down here, waiting on a tornado to take Carbondale out, right? You know what I mean? And, and then here I am, you know what I mean? So you see, the book's right, and that's why I told you, if all else fails, do you trust me, do you trust the PowerPoints, or do you trust the book? The book, for the most part, is the one that's been looked at the most. So, good point, right? You with me? You still like me? Huh? A little bit? All right. So anyway, here we got 600 tons, right? We got supply of 600 tons, and we have demand of 600 tons, so that should be fairly straightforward, right? And then, how much does it cost for me to go from Kansas City to Chicago? What's the cost? I'm going from Kansas City to Chicago, cost me? Kansas City, this costs me $8, right? So, now here, again, this is how they get tricky on you. Don't get taken in. What happens on the test if we make this A, B, and C, and we make this 1, 2, and 3? Is that legal? Yeah, and that's what they're going to do to you, because, hey, they're going to set you up, and you're going to assume that all A, B's, and C's are origins, right? And that these are the destination, and they'll switch it around, so don't get taken in. I'm trying to help you out, right? So if we're going to model this, we got X1A, X1B, plus X1C should equal what? Not this one, 200, right? Is that right? All right. We're going from Kansas City to Chicago, to St. Louis, to Cincinnati, right? Then we got Omaha to Chicago. We also have from Des Moines to Chicago, Des Moines to St. Louis, and Des Moines to Cincinnati. Again, if we're mixed up, let me unmix it for you. Here again is this a transshipment? No, because it's going directly from the origin to the destination, right? Supply to demand. So, where do we get our 6-1A? Where's the 6 at? Anybody pick up the 6? Kansas City to Chicago. Plus 8-1B, right? 8-1B plus 10-1C, right? Should equal 150. Yeah, see, I goofed up. it's the 150, it's down here. See, I told you I'm not perfect, right? You know, it's because there's only 150 that Kansas City has that it can get rid of, right? So it has to equal 150. Can it ship 151? No, it don't have it. Can it ship 149? Well, it can, but somebody's going to come up a ton short somewhere, right? So again, like in this course, if you really want to know the answer, you're going to put it into Excel. But what is important in life is to model it. If you can take a situation and you can model that situation, it's much easier for you to understand it then, right? So at any rate, do you understand each one of those as I've explained them to you? You know, your Miranda rights here. And so again, if you have x1a plus x2a plus x3a is equal to 200, where does that come from? Right? Yeah, there you go. Now we could map this out, all right? And overall, you see, this is still like the linear program we did. What are those subject to? Those are our what? Constraints, right? And what is that top one? We're going to minimize, right? Do we want to maximize cost or minimize cost? We want to minimize it, right? So again, guys, don't don't get upset here. I got everything. We got it covered. What's the worst grade you're going to get in this class? Yeah, right? How do you get an A? Outrun the person or beat them over the head next to you, right? You know, break their foot. You know what I mean? You know. So, okay. So let's take a look here. Again, is it Christy? Yeah, Christy. So here again, here's your explanation of how you put it. Here's your array, right? So again, from what is this? This is 5 here, right? So from K5 until to M, 8M or 7M here, right? And do we have that in here? K5 to M7. That's our array. You got this is what it's going to pick on to find those costs, right? To minimize it. And then here is, here's our decision variables are in here. We're going to figure out how much of each one of these are sent and received to supply and demand. And you see again, it equals the sum of the product C5 to E7. 5. C5 to E7. We want to fill these in here, right? Do I want to ship as much as I can at $15, or do I want to ship as much as I can at $5? $5, right? I'm going to put as much as I possibly can in there in order to minimize my cost, right? And then if you run it through here, right now the cost is equal to 0, but down here is where you're going to get your minimal cost. When you go home, you do this, you put this information in, you write all these in. That's why I give you the example here. You're going to have an example with 10 points, right? You take it, you try to solve it. Anybody having troubles because of the difference in the year of the Excel? Because it's from, the version of it. Because the 2013 is going to have some slight different commands than 2007 or in 2010. So you may run into those problems, right? At any rate, this is how you would, now do I expect you to do this on the test? No, right? Because you don't have enough time. You only have 2 hours, right? It's multiple guess. It isn't, you don't have time to go through that. But this is why I'm giving you, and we're winking and nodding, can you get the full amount of credit on it? You can, right? So, okay. Now again, here's QM. Well, no, this is again, how you would set it up here in Solver. And then what is your minimum cost? When we put it all through and we, put all these things in, and I'm going to give you an example, and you can go through to your heart's content if you want to spend the next 24 hours going over that question. But what is the cost? 4525. Can I beat that cost? Is that optimal? Nope, it's optimal. You're not going to can't go $1 lower than that. This is the optimal answer. Now, can I get other answers that are above that? Yep, I can. Okay. Oh, you guys, you want me to come back and yell at you some more and tell you some dirty stories that make you happy, So here again, when we're done, this is what's going to happen here, and this is how many tons of each one we're going to send. And if you notice here, like here's your 25, and here's your 25, right? So in your own time, go take a look at this thing. All righty, and here's your Excel. And this is with QM, so don't worry about going over, QM, because you can do it in Excel better, okay? So, how you guys doing? Anybody want to yell? You know, you want the door open, make it a little bit, gonna get some coffee here. Who's the worst teacher you ever had? Jim Roger, right? Who's the best fighter pilot you ever saw, right? Right, Steph? You're looking at her, honey, you know, so looking at him, honey. At any rate, never mind, movies. Now we're gonna go into a transshipment, right? You know what I mean? If you catch these things, like, you're half crazy, so don't worry about it, right? Now what happens, what's here? Do we have, you know, the record of the Edmund Fitzgerald? Does anyone know where the love of God goes when the waves turn the minutes to hours? Right? She was 26,000 tons more than the Edmund Fitzgerald weighed empty. Not making any sense. Yes, sir. Who is it? Gordon Lightfoot? Yeah, okay. So we could be talking about wheat. We could be talking about corn. We can talk about iron mill, right? You know, she was going to some mill in Wisconsin, and she might have broke up. She might have capsized. She may have broke deep and took water. But all that remains are the...
I like sundial.
Yeah. Something in the names of the wives and the sons and the daughters, right? So again, just think that what we have here is we have some sort of a warehouse before. You know, the ship's going to pull in somewhere. It's going to do. Somebody was telling me here, they saw on the History Channel how they take all the iron ore, then they pulverize it, and they put it in a solution, run it through the magnets, get rid of all the rock, and then take it, and that way when you're shipping it on these ships, you know, it's more efficient because you got iron ore and you're not shipping rocks, right? And if you watch the History Channel, you know, we're supposed to make you guys liberally educated, right? There's, you know, the cuneiform rock that was found in Minnesota. They think that the Leif Erikson or one of those guys showed up and left like cuneiform writing, that the Vikings were actually here in Minnesota looking for steel or looking for iron ore, and that they may have taken it back to Norway or whatever. So, at any rate, we got a transshipment problem because, problem. It's like Pittsburgh. It's a football town with a drinking problem, or a drinking town with a football problem. But we have a warehouse in between. So, you know, again, this is a question that's going to be on the test. So, you know, you can source this through the transshipment point. We can go there and then go to the destination. We can go directly from the source to the destination. We can go from the transshipment point to the destination, or any of those combinations. So if you see it on the test, would it be A, B, C, D, or all the above? All the above. We're 18 minutes and 16 seconds in, all right? So again, what are we looking at? Now again, we don't have the whole story here, but we're only going from the farm, you know? How are you going to keep them down on the farm when they've seen Gay Paris, right? Go from the farm in Nebraska and Colorado, we're going to go to the grain elevator, and then is there, you know, where are we going to go to the final destination? Now again, what's the cost here? Do we still have costs? What are our costs? How much from Nebraska to Kansas City? If you, now that you're in Dr. Rogers' class, right, in Mr. Rogers' neighborhood, Gesundheit, yes, ma'am. See that? You all right? Yeah, yeah. We're in Mr. Rogers' neighborhood. You can model for me now, right? Any guys want to model for me? You want to come up here in the catwalk, right? X1, 16, X1, 3, right? So I got you trained. You see that? That's what you're starting to think of, okay? So let's go through here. Now again, you know, if we set up this transshipment, you know, it's going to cost $16 to go from Nebraska to Kansas City. It's going to cost $12 to go from Nebraska to Des Moines, right? There's 300 here in Nebraska, 300 here, so that's 600. And then how many do we have over there? 300, 100, 200, balanced or unbalanced? Balanced again. Easy ones. Now there's some unbalanced ones on the test, so you're going to have to look at that. Now I'm going to give you a Roger Pearl that shows you how to, I'm going to give you the key to Rebecca so that when you see it, and if supply is greater than demand or demand is greater than supply, I will show you the algorithm to use, all right? You already have it there. So now we're going to go through and we're going to model this thing. We're going to do it the same way that we did before. So does anybody see where the 16x13 comes from? Where does the 16 come from? 1 to 3. 16x13, right? Everybody see it? 10x 14. 10x14. 10x14, right? So you just follow through. What's this thing called? Our profit or our minimization, right? We're going to maximize or minimize that. That's what that's up the top here, right? And then what are our constraints? What constrains us? So from 1.3 to 1.4 to 1.5, how much do I have? I got Nebraska here. I only got 300 to work with, right? We're working with a short poke here, right? I only got 300, right? 1 to 3, I go 1 to 4, I go to 1 to 5. You pick them how you want, right? I can only send so much. Where do you think I'm going to try to send the most of it? Yeah, right? Or going to probably go to 5, like what it got, 12, yeah, 4, right, 10, right? See, you're back, you got a better view than I did, right? Minimize, right? You're going to minimize it. So this is all you're doing. You're modeling the thing, and take a look at each one of those. Now, if you notice, what are these signs here? Equals, right? Why are these equal to equal? Because it's balanced, right? If it was unbalanced, you're going to have some less than or equal to because you got more supply than demand or more demand than supply, and we'll show you that. Now again, what does this tell me right here? What does this do that is different than a transportation problem? Why is this a transshipment problem? What's this doing? What's it saying? x13 plus x23 minus x36 minus x37 minus x38 is equal to 0. Garbage in's garbage out. Whatever wheat goes in, the wheat's got to go out, right? Because it's balanced. I don't want any, do I want any left in the mill? Right? I wish David Gray was here, you know what I mean? We could talk, exchange war stories, you know what I mean? You know, I was working for MTS, and my project manager had one job. That job was, when that contract was over, there better not be any money on the table. If there's any money on the table, the government didn't pay us. By God, that was money out of our pocket for profit, right? Do you want that? No, right? The other thing is, you better not have gone over at all, because that means you own the government and now you own interest, right? That was his job, basically, right? Well, your job here in transshipment and balanced is don't leave anything, you know, hope the rats don't eat anything in the warehouse that I don't have as many tons to ship out as what I got in, right? So let's go back. Take a look again. x13 plus x23. So it's going into the grain elevator there, right? And then it's coming out of it to 36, 37, and 38, and it's got to equal 0, right? Oh, Jimmy. So, let's see again here. Let me. 1, 3, 2, 3. So, 1's going into 3, and 2's going into 3. That's the only thing in. So, whatever goes in, now it can go out here. 3 can go to 7, it can go to 6, and it can go to 8, right? And how much do I have to work with? Nebraska only had 300 to send in, but how much of it went in here to Colorado? So whatever I take into any one of those, I got to take out so that it is equal. Again, it's not rocket science. It's pretty straightforward. The balanced ones are very simple, right? So here again, if we were to use Excel, what's your favorite application? Yeah. And here again, it's the same thing. Here's the hard part. You know, this is where you have to have the knowledge to be able to write these, right? And this comes from what? Experience, right? Do you guys want to spend the rest of the summer writing Excel code? Huh? I don't know if I'm smart enough to do that, right? But if that's what you want to do, there's all kinds of examples here that are in your book that you can take a look at. Do you get a CD-ROM with the back of that? You pay thousands of dollars. Huh? Yeah.
Just a scratch-off code.
There's no, is that a scratch-off code? And you're not even going to use that scratch-off code. Yeah, because, you know, these book companies, they're out to, you know, the lady, again, sorry, but, you know, I'm sitting there in my office minding my own business, right? The lady from Pearson comes in. You ordered the wrong book. oh, I'm sorry, excuse me, hey, one more person mad at me, I'm sorry, I mean, I just got rid of the student was mad, dean was mad, my chair was just mad, I mean, I got off the phone with my wife, she's upset, kids are bawling, the dogs, now, okay, so now on top of that, the lady comes in, hey, I'll take a shot at Jim Roger here, okay, and I mean, okay, well, hey, listen, Pearson, for the latest edition of the book, we can charge you like $220, but if you get two older editions of the book, why, maybe they're only like $50 of that. And when you put your order into the bookstore, you got the old edition, the 5th edition, and not the 6th edition. I said, well, I didn't even know there was a 6th edition. Well, I sent it to you. And then I said, well, I don't know. I said, here's the one you sent me, and it's the 5th edition. Well, look at all those boxes you got there. Are you sure you went through all your boxes? And I said, lady, if you can find any books in those boxes, I don't. Right? This is what I got to put up with, right? So, again, what's going on here? They want you to go in and use their software with Pearson and have an access code for it, and we're not even going to use it here. Why would I use Pearson's access code to their website that doesn't work when I can, for free, through your tuition, use D2L that doesn't work, right? So, is D2L going to be down on Sunday? So just so you guys know, I don't want to get an email. I was going to do the test. I was in the middle and it went down, right? It told you that, right? And probably that'll happen with Dr. What's his name? Slack, right? Because you guys will be in the middle here. Anyway, same thing here. It stopped recording. That's all right. Whatever the hell. I still got enough for that. Here again, what's your array? Here's your array. These are your costs, right? You'll see them up here. Here again, you got two different costs now because it's a transshipment because you got these elevators in the middle. It's a little bit more complicated, right? Here again, it's going to fill in with how many of these tons, how many of each ones we're going to send and what's our minimum cost going to be. 12,400 in this case with the transshipment, okay? Okay, guys, just hold on. We're almost done here. Yes, sir.
On this example,
Uh-huh.
is there some assumed limitation on these transshipment locations that you can't ship them all to one location?
And you know what? Again, you throw a book at me if I don't answer your question. On the cheat sheet for tonight, if I shut up long enough and don't tell you stories, let me give you an example of that one. On the test, you'll see one where in the middle you're going to have two transshipments, warehouses. One will take 600, one will take 700. Now what you have to do is you have to model that, right? And I'll show you that constraint and how that constraint's modeled, right? That's your job for tonight. You make sure before I walk out of here that I go over that because it's going to be on the test and it's a good question, right? But I can answer it better if I show you a specific example, but I don't want to get to that right now, okay? Is that all right? You all right with me? She's still going there, my friend. Okay. So, at any rate, here's this. Now again, here's what, once we're done here, these are, how we would do it. So, we have supply at the source, SS, right? And we have demand at the destination, right? Now, this is an assignment problem, right? Can I, hate to get religious on you, but Solomon, what's the story of Solomon? What happened? Was it Solomon? Hell, I don't know my religion too good. That's why they threw me out of Palestine. Was it Abraham? There was a kid, and both the people wanted a kid. What was Abraham going to do with a kid? Cut them in half, right? Right? Now, can we take a referee for the NBA and saw them in half and send the top part to one and the bottom part to another one? No, we can't do that, right? So in an assignment problem, this is what we're looking at here. And take a look. Now, again, guys, I can, I don't like to be tricky, but I got to go with what the book did. I'm just trying to, I'm giving you a heads up ahead of time. Now, if we're going to model this, right, this is A to R, A to A to D, A to C, right? That's the way we go. Could we put 1, 2, 3, and 4 up here and make this A to 1, A to 2, A to 3, and A to 4? We could, right? Could we make this 1, 2, 3, and 4 and make this RADC, so make this 1R, 1A, 1D, and 1C. We can't. Be aware of that, because I think some of you got mixed up a little bit on the test because, you know, they switched it up on you, and it looked a little different. But you have to go with what, you know, the parameters are here. So again, now what are these? These are miles, right? So for official A to go to Raleigh, it's going to be 210 miles, right? Is that good? You think you want to send them there? If just visually inspecting it, where would you think you would want to send him? Her, her, sorry guys, girl, ladies, you know, I'm like, hey, I'm politically correct too, you know, right? Looks like maybe I should send A to Atlanta, right? If I visually look at this one, well, hey, wait a minute, here's B, I should send him to her to Atlanta also. So we can't visually inspect it and come up with the correct answer. We got to run it through the mill, so to speak, right? And this is what we're going to do. So again, here again, notice what's going on here, guys. What do we got here? Equal signs. Why is it equal? Because it is a balanced, right? One official. Could we have an assignment problem that is unbalanced? Like me, right? We could, right? Say the professor has 4 tasks to do and only 3 students to do it. And we can say that student has to stick with 1 task, right? One of the tasks is not going to get done. Or if we do split them up on the tasks, probably 2 or 3 tasks are not going to get done. So again, depending on your parameters and what you want, and it depends on how you would set it up. So here again, you know, I don't think I have to go through this again. There's your Excel, and here again is the assignment. And so the total mileage, what do we want to do? Maximize mileage or minimize mileage? Minimize, right? Is 450. So where's the official A going to go to? Atlanta. Where's B going to go to? Raleigh. Where's C going to go to? Durham. Where's official D? Again, these are agents, you know, like James Bond, Special Agent 007. These